Hi. So we are going to start with a new section which is on heat. And when you say heat, first thing that you remember is the sense of feeling. When you touch something, you feel hot. When you touch something, you feel cold. And what this whole section is going to talk about is about this thing called heat, which makes something hot, makes something to melt, makes steam, and then all the associated things related to that in terms of what is boiling, what is melting, what is freezing, what is condensation, what is evaporation, what is sublimation. Oh, there is a lot of terms here. But there's nothing that you need to get excited about or perplexed about, because I'm going to take each of this and try to explain to you what each of this thing mean. And then probably we will also see some small video snippets which gives you a little bit more um, idea of what these things are. So in module 1, I'm mostly going to deal with a lot of terminologies, a lot of definitions, which are important when you think about heat. I'm going to start off with what is the heat energy, and then I'm going to go move into things like what is the impact of heat, what does heat do to environment, to things. Heat can do different. Heat can actually influence or create an impact. For example, heat can melt things, heat can boil things. So there are a lot of things which heat can do. So what does the heat do? And then after that, I'm going to explain different processes like boiling, melting, freezing, condensation, evaporation, all these different processes which are very much connected to this concept of heat. So I'm going to explain what all these processes are and probably define them, explain some of the characteristics of these processes. So, so welcome to heat, and I'm sure you're going to enjoy it. So, what is heat? I'm sure that in sixth grade and fifth grade, probably you would have heard or you would have learned that heat is a type of energy. You might have heard about different types of energy. There's electrical energy, mechanical energy, heat energy, light energy. So there are different kinds of energy, and heat is one kind of energy, which is extremely important. In fact, the greatest thing that our dear sun gives to us is heat energy, and without that, of course, there's light, there's heat, and a lot of other things, but heat is very important. And without that heat, our planet would have been a very cold, barren, absolutely not at all interesting place to be in. So heat is so important, and all that heat that our dear planet has is from the great friend of ours, who is the sun. So with that note, I'm going to start the module 1 on heat. And so what is heat? And the definition of heat is that it is the energy transferred from one body to another due to temperature difference is called the heat energy. So the heat which is transferred from one body to another body because of temperature difference. So the key word here is energy transferred due to the temperature difference. Very, very important point. That is what the characteristic of heat energy is. It's energy transferred from one body to another because of temperature difference. Let us take an example. When I hold ice in my hands, I feel it's very cold. And why do I feel it's very cold? Is because ice is at 0 degree. My hand is the body temperature, which is around 37 degree. And then what is happening? There's a temperature difference. The ice is 0 degree and my hand is 37 degree. So my hand is hotter or having a higher temperature than ice. So the heat is transferred from my palm onto the ice, and that's why the ice starts melting, and we'll see why it melts later on. But because that heat is flowing out of my palm, I'm feeling cold because I'm losing heat. And when I lose heat, I feel cold. Whereas, what happens if by accident I touch a hot iron? You know what is an iron, right? So iron is used to iron the clothes. I'm sure you have seen your mother doing that or your father ironing your school uniform and so on. By accident you happen to touch the hot iron when just when the ironing is going on, and what do you feel? You'll feel a terribly hot. Your finger gets hot. You might get a burn also. Why does it happen? It's because the hot iron is at a far higher degree. It probably is at around 80 degree to 85 degrees centigrade, and your finger is your body temperature. Now, which has got a higher temperature? No, it's the iron has got a higher temperature than your finger, and since there's a temperature difference, and since iron has a the ironing machine has a higher temperature than your finger, the heat is going to flow from ironing machine to you, to your finger. And since the heat is flowing into you or into your finger, you're feeling hot. So that's what heat energy is all about. Heat energy is a type of energy which gets transferred from one body to another because of difference in temperature. So if there is no difference in temperature, there is no flow of heat. So when I touch another, when you touch your friend, you don't feel either hot or cold. Why? Because his body temperature and your body temperature is exactly the same. And since both the body temperatures are the same, you don't feel either hot or cold. So when you are having both the temperatures same, you don't feel either hot or cold. This is because there is no flow of heat at all. Because there's no difference in temperature. It's only difference in temperature which will trigger a transfer of heat energy from one body to another. So I think that will probably give you a very good idea about what does heat energy mean. It's a type of energy which is transferred from one body to another because of due to a temperature difference. And I gave you a lot of examples, and I think that probably gives a clarity on what heat energy is all about. So, what is the effect of heat energy? Of course, we saw some, right? We saw some effect of heat energy. If I go and hold ice, I feel cold. If I go and touch a hot ironing machine, I feel hot, right? So these are all some of the effects. But what are the effects? One of the very key effect of heat energy is it brings about change in temperature, right? It does bring about. So let me explain. When I let me take a bowl of water and put it on a gas stove and burn the gas stove. And what happens to the water inside the bowl? You can see that in the course of time, the water temperature starts going up, and at some point it starts boiling. I'm sure you have seen your mother making tea, right? And she has to boil water when she has to prepare some tea for you, or for your father or your friends. Now, how does that happen is because when I put the bowl on the burner, the water in the bowl is at the room temperature, which could be 25 degrees centigrade. whereas the burner is at a far higher temperature. It's more than 100 degrees centigrade, probably 150, 200, 250 degrees centigrade. So now what is happening is that the heat is going to flow because the flame is at a higher temperature. The heat is going to flow from the flame onto the bowl and then into the water. So because of the flow of heat, it is bringing about a change in temperature, and that is precisely why. So that means when a heat is flowing into something, its temperature is going to increase. So here the heat is flowing from the flame into the water, and so the water's temperature is going to increase, and in the course of time the water will start boiling. So that is about the heat brings about change in temperature. Let us take another example. On a winter day in morning, before 5 o'clock, before the sun rises, it's really cold. Yeah, the atmosphere is cold and you feel very chilly and stuff like that. I am from Bangalore, and Bangalore does have cold climate. And in the months of November and December, it's pretty cold in the morning. It will be less than 5 degree, probably 6 degrees centigrade. And then the sun rises. And when the sun rises, slowly you'll feel it's getting warmer and more comfortable. Why is that happening? Again, the heat is coming from the sun, and when the heat falls onto the atmosphere and let's say air, it starts getting a little bit heated up. It falls, the sun rays and the heat from the sun falls onto the ground and the land, and it starts getting a little bit heated up and you feel warmer. Again, the effect of increase in temperature because of heat energy. So couple of examples, right? So heating an object, as I explained. Change in dimensions. When we discuss about density, in the mass weight density module, I explained about the effect of heat, increase in temperature, than which is brought about by heat energy, the effect of that on the volume of a substance, right? I even showed you an experiment where I am sure you remember the bottle and the balloon experiment, and when the air was heated, it was expanding. When the air was cooled, when the air inside the bottle was cooled, it was contracting and so on. So it leads to a change in dimension. The volume, the space occupied by the substance can change because of the temperature or because of heat. Similarly, if you take an iron rod and heat it to 500 degrees centigrade, it expands. You'll find that length would have increased because of the expansion. So that is basically the other effect. Very common effect of heat energy is also expansion or contraction. If you're cooling, it contracts, the volume decreases. If you're heating, the volume increases or it expands. So it depends upon what you do. So that is the second effect of heat energy. Then what's the third effect? Change in state. Boiling is an example. Your water is in the liquid state, and I boil water when it reaches 100 degrees. So I start heating, and when water reaches 100 degrees, which is called the boiling point, at that point, the water starts getting converted into steam, which is the gaseous state of water, right? It starts boiling and you can see steam coming out. So it's an example of change in state. And we are going to look at change in state in more details and all the different kinds of change in state. You can have a change of state from solid to liquid, or liquid to gas, or solid to gas, and so on, or opposite. It can be liquid to solid, gas to liquid. So all these are possible. We are going to look at what are all these various change in states which are possible, and we are also going to define those processes. What is the process of when an object is heated and it changes from a solid to liquid state? What is that process called, right? And so on. So we'll actually look at all that. So change of state example is boiling, melting, all freezing. All these are examples of change in state. So we'll look at all of them. So let us define what is change of state. Now, I'm sure that all of you would have learned about the states in which a matter can exist, right? There are three main states. You have the solid state, you have the liquid state, and you have the gaseous state. So we have three states in which a matter can exist. And we are talking about the change of state, which is from solid to liquid, or liquid to gas, or vice versa, which is gas to liquid, liquid to solid. So both are possible. All these are possible, right? So the process due to which a substance changes from one physical state to another physical state with absorption or release of heat energy is known as change of state. Now, the key words here is the change in physical state, one physical state to another physical state, because of absorption or release. So, now what does that mean? If you look at water boiling, it is because of absorption. The water is absorbing. It is absorbing heat from the burner, right? And because that heat is absorbed, water's temperature starts going up. And when it reaches a boiling point, because it's keeping on absorbing, and why the absorption is happening, why the heat energy flow is happening, because of the temperature difference, right? Because of the temperature difference between the flame and the water, the heat energy flows from from the flame to water, and because the heat energy is flowing, the water's temperature increases, which basically means the water is absorbing that heat energy which is flowing into it because of its temperatures increasing. And at the point when it reaches boiling point, it has got a change of state from one physical state to the other physical state, which is from liquid to gas. Now, that is about absorption of heat energy. But there could be also release of heat energy. For example, let us take a situation where I take a bowl of water and put that into the freezer in a refrigerator. And if I put that in the freezer in the refrigerator, after some time, what do you see? You see that the water's got changed into ice. And at that point, when the change from liquid to ice happens, there's release of heat energy. Why is the release happening? Why water is releasing heat energy? Why heat is flowing out of water? Is because the freezer is at a far more lower temperature. So when you're putting water inside the freezer, it's in room temperature, right? Because it was outside. So the room temperature would have been 25-degree or 30-degree based on where you are. And you're putting that inside the freezer where the temperature is sub-zero. It's less than 0 degree, probably -5 or -10 degree. So now there's a temperature difference. The water is far hotter than the air inside the freezer, which is -10 degree or -12 degree. So there's temperature difference where water is hotter than the air in the freezer, and so the heat starts flowing out of water, and hence, and when the heat when and because of heat is flowing out of water, the temperature of water starts going down. So it becomes 30 degree, then 20, 10, and so on, and it reaches at a point it reaches 0 degree, and that is what is called the freezing point, where the water starts changing its states from the liquid water state to the solid ice state. So that is an example of release where the heat energy is flowing out of water, and because of which water's temperature is going down, and because the temperature is going down, the water in the course of time, when it reaches the freezing point, the water changes from the liquid state into the solid state, which is ice. So this is what is change of state. So boiling, as I explained, because of absorption of heat energy. Condensation is another example. I gave an example of freezing, but condensation is another example where there's release of energy, where the steam is getting converted back into water. I'll explain this later on, so don't worry. So you got an idea of change of state because of absorption of heat. You have got an idea of change of state because of release of heat. Release of heat. Okay. So, what about freezing and melting? I'm just asking you a question. So, I'm sure that you can think about what it is. Freezing is where, from liquid it changes to solid, and melting is when it changes from solid to liquid. You can use the same logic which I explained right now for boiling and freezing. In fact, I explained right now. So, to kind of explain the change of state, always think the heat when the heat flows from higher temperature to lower temperature. So the object which is losing heat, its temperature is going to go down. The object which is receiving or getting heat, its temperature is going to go up. Right? So I hope when you go through the session, you're writing notes. It's very important. I talk a lot outside what you see as text. So you need to definitely write notes because that's going to help you a lot in understanding the subject and probably also helps you to grasp it better. So, simple thing, I'm going to repeat it once again. The heat always flows from the body which has got a higher temperature to a body which has got a lower temperature, and when the body which is losing heat, its temperature will come down or go down, and the body which is receiving heat, its temperature will go up. Right? So that is about change of state. Now let us get into melting or fusion, right? And try to understand what is melting or fusion, right? So before getting into the definition, I want to show you a small video. Now, what you're going to see in this video is, in fact, just a moment. What you're going to see in this video is, in fact, how ice melts. In what they've done is they've recorded it and they're playing it very fast. So you can see the melting. The melting doesn't happen so fast, but for the sake of time, I'm trying to show it in a fast forwarding fashion. So you can see as the time passes, right, the ice is melting, right? Don't you see the water coming here in the bottom? So you can see the water coming here at the bottom, right? So slowly the ice is melting and it's becoming water. This process is what is called melting, or it's also called fusion, right? So this is the process of melting and fusion. What exactly is happening? Ice is at a temperature of 0 degree. The outside, and you have put it in a wine glass, and you have put it outside in a room where the temperature is probably 25 degrees. So now the air in your room is 25 degrees and ice is 0 degree. So which way will the heat flow? Heat will flow from the air in the room, right? And also even the surface. So it is kept on a table. So even table is in the room temperature, 25 degrees, right? So from the table and from the air, all these places, the heat will flow into ice, right? So the heat is flowing into the ice, and then when the heat is flowing into the ice is getting slightly heated up, and so what will happen? And ice is 0 degrees, and that's the melting point of ice. So it will start absorbing this heat, and slowly it will start getting converted into water. That's what's going on. So heat is flowing from around from the air and from the table and all that, because they're all room temperature is far higher than the temperature of ice. So the heat is flowing into ice. Ice is absorbing all that heat energy, and then since it is 0 degree, which is a melting point, the ice slowly starts melting by absorbing this heat, and that is how you see more and more water. And as in the time elapses, you can see that the more and more ice melts and more water gets created. You can also see something going on. One more process is going on. Oh yeah, so science is fun, right? Now you can see what is going on around on the glass. What's happening? Another thing is going on there, and that is what is called condensation, right? What is that? So what is happening is that if you look at the ice, and the water. And in fact, the water which is getting produced due to the melting, even that will also be 0 degree. The whole melting process happens at a fixed temperature. So at the point when the melting is going on, there is no temperature change. Both the ice and the water, both of them are at 0 degree. Please remember this. Very, very important point. When the melting happens, the temperature is a constant, right? It just can't be that the water which is melted is at 10 degree and ice is at 0 degree. No, the whole thing will be at 0 degree. So the ice is at 0 degree and water is at 0 degree, and at a constant temperature, the melting will happen, which is 0 degree, which is the melting point of ice. So now what is happening is, so this whole glass which is containing this cold water and ice inside, the glass is very cold. Now, what is happening is, since the water is very cold, there is water vapor, right? Inside that, I'm sure is something that you've learned in the sixth standard, that air has water vapor. And water vapor is a gaseous state of water. Now, what is happening is that water vapor is coming in touch with very cool surface of glass. Now, what's going to happen? Which way will the heat flow? The water vapor is at somewhat in the room temperature, right? And the glass wall is, or the glass is at 0 degree, around 0 degree. So now the heat has to flow out of the water vapor, because it will flow into the glass wall, or into the glass, which is so cold. And so since the heat is flowing from the water vapor out of water vapor, what happens is that the water vapor is losing energy, and then it can condense into the liquid state. So that is condensation. So there are two things going on here. There's melting which is going on inside the glass, and there is condensation which is going on along the wall of the glass, right, outside surface of the glass. So, and you can see after some time the whole thing has become water. So that is basically showing how the melting happens. I'm sure that you would have got an idea. Now, well, let us get into the definition. The process due to which a solid changes to liquid at a fixed temperature by absorption of heat energy by heating by heating is called melting or fusion. When you say heating, it's not necessary that you have to put a flame there. Please don't think heating means you have to put a burner or some flame there. Not necessary. Heating can happen anytime when there's temperature difference. So in the instance which I showed, did I put a flame below the glass? No, I didn't. But it was still getting heated. Why? Because the outside temperature was higher than the ice temperature. So ice was getting heated up, because always the heat will flow from higher temperature to lower temperature. And since the heat flows into ice, ice absorbs the heat and it starts melting at the melting point 0 degree, and water starts getting formed. So once again, what is melting or fusion? The process due to which a solid changes to liquid at a fixed temperature, and that fixed temperature is important. At the point when the melting happens, there is no temperature change. It's always constant at the melting point. So in the case of water, in the case of ice, that melting point is 0 degree. So till all the melting is over, the temperature continues to be at 0 degree. At fixed temperature, by absorption of heat or by heating, is called melting or fusion. Temperature, and the temperature at which this happens is called melting point, or it's also called fusion point. So for ice, the melting point or fusion point is 0 degree centigrade. Now I've put something else on the slash 273K. I don't know whether you've heard about that, but I'm sure you've heard about one thing called SI unit system. That is something which I taught you, in the mass volume density modules. I explained what is the SI system. SI system is a unit system which is used universally by everybody, and the temperature in SI unit system is always in Kelvin. Okay, so and 0 degree is equal to 273 degree Kelvin, right? Kelvin is again based on a scientist who has done a lot of things related to heat energy. You will learn about Kelvin maybe in plus one, plus two, right? But don't worry about what he has done right now. We'll look at that later. But Kelvin is a very famous scientist. So if you want to convert from degrees Celsius to Kelvin, only thing you have to do is just add 273. So if you want to convert 100 degrees centigrade to Kelvin, just say 100 plus 273, which is 373 Kelvin. So 100 degrees Celsius is 373 Kelvin. So if you want to convert degrees Celsius to Kelvin, just add 273 to the number in degrees Celsius and you get Kelvin. So that is another important point. So you have also learned what is Kelvin and how I can convert degrees centigrade to Kelvin. So here you can see 0 degree plus 273 gives me 273 Kelvin. So when you say fusion or melting point of ice, it is 0 degrees Celsius, or you can also say 273 Kelvin. Okay, it is just like converting between kilogram and gram, so something like that, right? Similarly you can convert from Celsius to Kelvin. Just add 273 to the Celsius value and you get the Kelvin value. So what is the melting point of tungsten? I'm sure you've learned about tungsten last year in science, right? When you learned about a filament bulb, and you have learned that the filament of the bulb is made of tungsten. The reason why it is made of tungsten is because it's got two things. The first thing is what you call resistance, right? And that you'll learn later when you learn about Ohm's law and electricity. But the other very key part is it's got a very high melting point. Its melting point is about 3000 degrees centigrade. And so since it's a very high melting point, tungsten is used, right? So the melting point of, so I want you to go and check in your textbook or wherever or internet, and you please figure out what is the melting point of tungsten. I want you to figure it out yourself. It's a homework for you, right? And since I just told some number, I'm not sure whether it's right. So I want you to check whether it's right. I just told some 3000 something, right? But I don't know whether it's right or wrong. I want you to check it. So you please find it and let me know what is the melting point of tungsten. Melting point tungsten is very high, and that's why it is used in a filament bulb, because as you know, in a filament bulb the temperature of the filament really goes up pretty high, and if it melts then the filament will just break. So it just can't do that. So it has to be a material with a very high melting point. That's why tungsten is used, right? So that is about melting or fusing, right? What is freezing? Again, I want to start off with a video on freezing. Again, this is a high-speed video. It's being played at a very high speed. In fact, the freezing will not happen so fast. So what they've done is they've recorded and they're playing it very fast so that to save time, right? So you can see this is a glass of water which is inside a freezer, and you can see how it is melting. And here's where the ice is getting formed. So here's where the ice is getting formed. So it is melting, right? And slowly what is happening is that more and more of water is getting it's freezing. I'm sorry, not melting, freezing. So you can see more and more of water is freezing, and in the course of time the whole water is frozen into ice. Now why is this freezing happening? What is the reason why freezing is happening? The freezing is happening because the freezer in which this glass is kept, the freezer in which this glass is kept is at sub-zero degrees centigrade. It's probably at minus 15 degrees centigrade. And the water which you kept inside the freezer was at room temperature, which probably was 25 degrees centigrade. So which has got a higher temperature? Water has got a higher temperature. The air and the surface, this freezer surface on which you have kept the glass, all these is at a far more lower temperature, minus 15 or minus 20 degrees centigrade. So there's temperature difference. And which way will the heat flow? The heat will flow from water to the air and the surface on which it is kept on the freezer and so on, because all that is minus 20 degrees centigrade. Water is at 25 degrees centigrade. Water has more heat. As I told you, heat always flows from the object or the substance which has got a higher temperature to the object or substance which has got a lower temperature. So here freezer has got a lower temperature, and the water has got a higher temperature. So the water starts releasing energy, or it starts losing energy because of temperature difference. And when it starts losing energy, what will happen? Slowly, the temperature of water starts going down. As I told you, when a substance or an object loses heat, its temperature starts going down. So here, the water's temperature starts going down, and in the course of time, it was 25 degrees, then it becomes 20, 15, 10, 5. It goes on one by one degree centigrade. It goes down, and ultimately it reaches 0 degree. At the point when it reaches 0 degree, the water starts going through a change of state, which is opposite to melting. In melting, the ice was melting into water, but here it's just the opposite process, which is called the freezing, where the water is undergoing a change of state from a liquid state to solid state, where water is moving into ice. And as and when the temperature goes down and reaches 0 degree, it starts freezing, because that is what's the freezing point of water. That is the temperature at which, it's a constant temperature at which the water gets converted to ice, or it starts freezing. So this kind of shows what's going on inside a freezer, and that is how in freezer you're able to produce ice. So don't you feel excited because you've learned how ice gets formed in a freezer? Wow, that's cool, isn't it? Yes. All right. Now let's go back and look at. So I want to now get into the definitions, right? So the process due to which a liquid changes to solid state at some fixed temperature due to release of heat energy by cooling is called freezing. That's what you just saw now, right? A liquid changes to solid state. The water was changing into ice at a fixed temperature, which is the freezing point, which is, in the case of water, 0 degree. So you can see the melting point and the freezing point are the same. Didn't you see that? The melting point was 0 degree when the ice gets converted to water, and the freezing point is also the same. Ice gets converted to water gets converted to ice. So the melting point and freezing point of water is the same. And typically, always the melting point and freezing points of substances usually is the same, right? So, and why is that? Why is the change of state happening? Because it is releasing heat energy. That's true, right? Water was losing heat energy. Initially it was 25 degree, then its temperature starts going down because it was losing energy. The reason is because water was far hotter than the surrounding atmosphere in the freezer, and so it started losing energy. The heat was flowing out of water, and hence the temperature of water was going down. And ultimately, when it reached the freezing point, it starts the change of state from liquid to solid, and that's what we saw, right? So that is what. So the process due to which the liquid changes to solid state at a fixed temperature due to release of heat energy. In the melting, it was absorption. Here it is the freezing. It is release of heat energy by cooling is called freezing. The temperature at which this happens is the freezing point. So it's a freezing point where this liquid changes to solid state, and so it's called a freezing point. And in the case of water, the freezing point is 0 degree. And as I told you, the freezing point and melting point will be typically the same. So the water freezes into ice at 0 degree, or as I told you, 273 Kelvin, right? All right. So what happens in refrigerator? That's what I explained just now, right? What happens in refrigerator? So I want you to explain that to you yourself and what happens in the refrigerator. I just explained what happens, right? And you just saw that in the video, what is going on in the refrigerator. Now, the next process which I want to talk about. So we looked at melting, looked at freezing. Both was to do with liquid and solid state changes. Melting was from solid to liquid, and freezing was from liquid to solid. And we also saw that melting happens in melting point and freezing happens at freezing point. All right. Okay. So now let us look at vaporization. So now we are going to deal with liquid to vapor and vapor to liquid, or liquid to gas, gas to liquid. Sorry. Right. Liquid to gas and gas to liquid. So the others, that's the next state change which is possible. Right. So let us look at vaporization. Now for that, I want to probably show you an experiment or a small video. So here is a jug. I don't know. I mean, probably you may have what you call a kettle in your kitchen where you used. It's called the electric kettle, which can be used to heat water and boil it. So here you can see a electric kettle like that, and you can see what is going on here, right? You can see the water boiling, right? And why is that boiling? Why is the water boiling? What is the reason why water is boiling? So let us see it a little more slower. See? So you can see that water is bubbling, right? And it's boiling. Why is it boiling? What is the reason? And what is that bubbles of? That bubbles are of steam. And why the bubbles of steam is formed is because there's a change of state happening from water to steam or water vapor, which is the gaseous state of water. And why is that happening? The reason is because this water kettle has got what is called a heating coil at the bottom. So here in the bottom there is something called a heating coil which gets heated when the electricity flows through it. Now how it gets heated? Very wonderful question, but I'm not going to answer it because you have to learn electricity for that, right? So you will learn that probably in a higher class. There's something called Ohm's law, which is a basic law which talks about the electricity and the flow and resistance and blah blah blah. But we're not going to discuss about that now. But you should believe in me and trust me that this is got a coil, heating coil, which is made of a specific substance. And when the electricity flows through it, it gets heated up. And because it gets heated up, it gets heated up to maybe 200 degree or something, pretty high temperature, a big temperature. And the water which is inside the kettle is room temperature when you when you pour it inside the kettle, it's a room temperature. 25 degree, 30 degree temperature, degree Celsius. And the coil is at 200 degrees Celsius. Again, difference in temperature. Which has got a more temperature? The coil has got more temperature and than water. So which way will the heat flow? Heat will flow from the coil onto the water. And when the water is, so now water is receiving it. Water is absorbing heat. And when something absorbs heat, what happens to it? Its temperature starts increasing. And so here what is happening is that the water's temperature starts increasing. So it starts increasing from 25 degrees, then goes 30, 35, 40, it starts going up, and probably after a few minutes, the water will reach a temperature of 100 degrees, and that is called the boiling point, and that's the temperature at which the water will start changing from a liquid state to a gaseous state, which is, in the case of water, is called a water vapor. So that's what's exactly going on inside this kettle. And you can even see that effervescence or bubbling on the surface of water, right? Very clearly seen here. That all those bubbles are full of steam, which is water vapor. So we are actually seeing boiling going on. And that is what is vaporization. Vaporization, let us get into the definition of vaporization. The vaporization is a process due to which liquid changes to gaseous state. Liquid changes to gaseous state at some fixed temperature because of absorption of heat energy by heating is called vaporization or boiling. So again, process due to which changes happening from liquid to gaseous state at a fixed temperature, which in the case of water is 100 degrees Celsius, or what's in Kelvin, 100 plus 273, which is 373 Kelvin. So, so the boiling point of water, or it's also called the vaporization point of water, is 100 degrees Celsius or 273 Kelvin. So, at that fixed temperature, the water will change from liquid to gaseous state. And why is that change happening? Because of absorption of heat. Where was it absorbing heat from? From the hot filament of or hot coil, so hot heating coil, which was there inside the electric kettle. So that is what's going on. The temperature at which this happens is called the boiling point or the vaporization point. And in the case of water, it is converting into steam, which is nothing but hot water vapor. And what is that difference and that steam is basically the gaseous state of water, and so water is converted to steam at 100 degrees centigrade or 373 degree Kelvin. So that is about vaporization. I hope it's clear. So we have looked at melting, which is from solid to liquid state because of absorption of heat. You have seen freezing, which is liquid to solid state because of release of heat energy, right? Then we have seen liquid to gaseous state because of absorption of heat, and that is vaporization, right? And so we've seen melting, freezing, vaporization. Now we are getting into the next thing, which is the condensation. I already spoke about condensation, didn't I? When I explained about fusion, you saw those small water droplets sticking onto the cold glass surface when the melting was going on, and I told you what is that? That is condensation. I want to show you another video of condensation right here. Now, what is going on here is that this pipe is connected to what is called a boiler. I don't know whether you've heard about a term called boiler, right? Boiler is nothing but something you can say which can produce steam, right? So it can produce steam. So there's a lot of steam getting produced inside this boiler. How? Don't worry about that. You boiler is a heat exchanger and blah blah. There's a lot of stories to talk about there. It's a big area in mechanical engineering called heat and mass transfer. So don't worry about that part, right? Just leave it. But you can say that there's something called a boiler which can produce steam, and then the steam is flowing out of this pipe. From the steam is produced out of its outlet from the boiler, and then see what's happening to the steam when it comes out. You get, don't you see something? You can see this. Don't you see water here? How is it water formed? And then when it goes down, you can also see that if you look at steam, steam is not white in color. Steam is not white in color. Steam is absolutely transparent. But why is that whitish color coming? It is because of condensation. Why is this water seen here? It's because of condensation. What is happening is when the steam comes out of the boiler, it is coming out to a cool atmosphere. So outside, so inside this boiler, probably it's above 100 degrees centigrade, but outside it's probably 15 degree or 20 degrees centigrade. And so when the steam comes out, steam is very hot. Steam is hot 100 degrees centigrade. Outside is 20 degree. The outside air is at 20 degrees centigrade. So which is colder? Air outside is colder and steam is hot. So who loses energy? Which way will the energy flow? Energy will flow out of the steam into the air, isn't it not? And when the heat energy flows from steam to the air, what will happen to steam? So steam may be 105 degree or something, right? Its temperature starts coming down 102, 103, 100, I mean 104, 103, 102, and so on, and then reaches 100 degree. And when it reaches 100 degree, it is the point of condensation. That's a point when the water changes from gaseous state to liquid state. So that's what's going on here. So that's why we see water. That's why we see water here. That steam is condensing into water. And even why are you seeing this whitish stuff? That white stuff, that whitish thing that you're seeing are tiny water droplets which are getting produced because of the condensation of steam. That's why it is looking like a white fume or white smoke. That is because of tiny droplets of water which is being formed because of condensation of steam. So this is actually showing exactly condensation happening. Is that clear? So here the steam is releasing heat energy, and it is changing from gaseous state to the liquid state. So just opposite to boiling, and it happens at the same temperature. Okay, let's go back and see the definition of condensation. The condensation, the definition is a process due to which a gas changes in the liquid state at some fixed temperature with release of heat energy by cooling is known as condensation. Very clear definition. Changes from gaseous state to liquid state at a fixed temperature because of release of heat energy. I assure you, right? When steam comes out of the boiler, the outside air is far cooler, so it is releasing energy because steam is hotter. Always the hotter substance, a hotter object, loses heat to the colder object. So here the heat is flowing from the steam into the air outside. And so when the steam loses heat, its temperature has to come down, and when it reaches 100 degree, it is the condensation point, and it starts getting converted to liquid form, which is the water. That's what's happening, right? So the process due to which a gas changes into liquid state at some fixed temperature with release of heat energy by cooling is known as condensation. So temperature at which this happens is condensation point, and for the substance called water, from steam to water, it happens. The condensation point is 100 degree Celsius or plus 273, which is 373 Kelvin, which is same as the boiling point. So noticing similarity of the melting point, freezing point relationship, right? Both were the same. Similarly, boiling point, condensation point also is the same temperature for water, right? So let us recap. So we have looked at what is heat energy. It's type of energy which transfers from an object with a higher temperature from one object to another because due to temperature difference. Then we looked at change of state because of heat energy. We have looked at melting. We have looked at freezing. We looked at vaporization. We have looked at condensation. But the change from a liquid state to gaseous state need not necessarily only happen because of boiling. That is a very, very important point. I don't know where you have tried. If you take a mug of water or a glass of water and keep it in sunlight, you'll find that probably by the time you come back from your school, half of the glass is empty. You don't see that water. Where has it gone? It has evaporated. Why is it evaporating? Is it boiling? Is the water at 100 degrees centigrade? No, it is not. It probably is at 30 or 35 degree because the sunlight is falling on it, right? So it's at around 30-35 degree, but still it is losing. You see the quantity of water in the glass has come down. And that is because of evaporation. So it is possible for the change from a liquid state to gaseous state can happen at a temperature which is below its boiling point. And when that happens, that is called evaporation. Another example, you have a wet cloth. Your mother has got wet cloth which she gets from the washing machine, and she just puts that on the terrace. And by evening, you find completely dry cloth. Why was it wet before? It's because there's water droplets inside the cloth. Why it gets dry is because of evaporation. Did I put the cloth at 100 degree? Was the water inside boiling? No, it is not. So the change from the liquid state to gaseous state can also happen at a temperature which is far below the boiling point. And that kind of change is called evaporation. So so I hope it's very clear. Now, the rate of evaporation, that means how fast the water evaporates into water vapor, or the liquid evaporates into its liquid state, into its gaseous state, totally depends upon the temperature. So, if it is a very hot day, you can see that the clothes get dry faster. That's because the rate of evaporation is higher, because the temperature is higher. Why is temperature higher? Because the day is hot. The day is hot, the atmospheric temperature is higher, and so your rate of evaporation also is higher. So the rate of evaporation increases when the temperature increases. So as I want to reiterate, the change from liquid state into gaseous state at any temperature below the boiling point is called evaporation. The rate of evaporation depends on the temperature. So higher the temperature, higher will be the rate of evaporation. And that is why when you have a hotter day, the clothes gets dried faster, right? So I answered this question. How does your mother dry washed clothes? And I think now I want you to think and answer the question yourself. And if you have understood that, I'm sure you have understood what's evaporation. All right. So that is evaporation. So if a change from liquid state to gaseous state happen at a temperature which is below the boiling point, that is called evaporation. All right. Now, what is sublimation? Oh, wow. That is interesting. You're saying that there is a change of state possible from solid directly to gas. Wow. What about liquid state? That is not right. Don't you think so? Oh, wow. Welcome to nature. Nature is full of exceptions, right? It is not necessary that each and everything follows exactly the same rule or law. Everything has exception. So there are materials which just change from solid to gaseous state directly. Let me show you an example here. So this is showing a process called sublimation, right? So what is happening here? Hi, welcome. So what is happening here? What you see here is nothing but dry ice. I don't know what you have heard about what is dry ice. Dry as ice is carbon dioxide in solid state. Carbon dioxide in solid state. I know that you see there's a lot of carbon dioxide in the atmosphere, but it's in gaseous state. But I can cool this carbon dioxide and make what you call the dry ice. So what you see here is dry ice, which is carbon dioxide in solid state. Now, I just have put the dry ice in a plate and see what's happening to it. Don't you see what around? Don't you see some fumes around it? What is that? That is carbon dioxide in the gaseous state. So what is happening is the dry ice, which is in a solid state, is directly converting or changing into its gaseous state. So that's what you see here. You can see the fumes around, and that's all the gaseous carbon dioxide. So this is sublimation. Sublimation is a process when a solid directly changes into gaseous state on heating, or gaseous state directly changes to solid state. So if you look at the how does the dry ice gets produced? The dry ice gets produced when you cool the carbon dioxide and it directly gets converted into solid state. There's no liquid state in between, right? So it can happen both ways. So there's the solid directly converting to gaseous state, and the gaseous state directly converting to solid state, and that process is called sublimation. So sublimation is a process where the solid state directly gets converted to gaseous state, as we just saw in the video, where the dry ice, which is the carbon dioxide in the solid state, which was directly getting converted into the carbon dioxide in the gaseous state. All right, so that is about sublimation. So let's just recap. So we have looked at what's melting, what is freezing, what is vaporization, what's condensation, and what is evaporation, and what is sublimation. Wow, I'm sure that there's too many terminologies that you've learned today, but It's all fun. And you're going to explain a lot of things around you using all these concepts that you've learned. And it's very important for you to know all this because they're all very key fundamental processes which happens in nature. And you can see that with all different substances. Now, so that's one impact of heat energy. One impact of heat energy is the change in state. It can make state changes from solid to liquid, liquid to solid, liquid to gas, gas to liquid, solid to gas, and all that stuff. And that's what you learned in all these processes. Another thing which the heat energy can do is to bring chemical changes. It can make chemical changes. And I'm sure that you may be remembering what you learned in physics last time, which is the reversible and irreversible changes. Do you remember that? So, you can have reversible changes and you can have irreversible changes. I burn a piece of paper and that is an irreversible change. You just can't create the paper back from the ashes. Why? Because it is a chemical change. So, and let me explain one example here. Calcium carbonate. I'm sure you've heard about marble. Marble is nothing but calcium carbonate. And if you heat marble to very high temperature, it actually goes through a chemical change where calcium oxide and carbon dioxide are formed. They are two other chemicals. So this is a chemical change where the compound or the chemical composition of the material is changing because of heating. Why is that happening? Well, that is something which we worry about in chemistry, right? So we'll not take that out. The fact that a chemical change could occur is what I want you to understand. And why calcium carbonate becomes calcium oxide and carbon dioxide? Why can't it be calcium dioxide and carbon monoxide? Yeah, it's possible. But they're all possibilities which can only be explained by chemistry. So we are not dealt with the chemistry yet. So let's not bother about that. But one thing you should remember is the heat energy, just like it can bring state changes, can also bring chemical changes. The other example is burning of a substance in air. That's a chemical change. For example, uh, let me take the example of burning of paper. When you burn the paper, what's happening? The paper after burning gives you black colored ash, which is mostly carbon, right? And that is a chemical change, and that chemical change happens with release of energy. And why? Because if release of heat energy, if you just light a paper and when it burns, if you put a finger near it, you can see the heat, right? You feel it's hot. That is because there is a chemical change happening which is releasing a lot of heat energy. Similarly, you burn a candle and you keep a finger near the burning flame, you feel heat. That's because the wax and the candle is burning, and that is again a chemical change, right? And there is a chemical change happening with release of heat energy, and that is what is called combustion. Burning of a substance and oxygen leading to chemical change releasing large amount of heat and light energy is called combustion, right? So I can give you umpteen number of examples. Similarly, the other example is the burning of the liquid LPG. That is if you see the burner, the gas burner in your kitchen, when you light it, it burns. Again, it's combustion. The If you look at the cylinder, the cooking gas cylinder has gas, and that gas is burning again in oxygen, releasing a lot of heat, and that heat is used for heating substances, and that is combustion again. So combustion is an example of burning of substances in air or oxygen leading to chemical change releasing a lot of heat energy, right? So that is what is combustion. So I gave you a lot of examples of combustion, and I want to give you, so what happens when a candle burns? As I told you, the wax is is burning in the presence of oxygen, releasing a lot of energy, heat energy, and that is what's going on when the candle burns. What happens in your car engine? Oh, that is fun. What's happening in your car engine? How does the car move forward? Do you know that the heat has a big role to play there? So, and the combustion is a big role to play there. I want to actually show you a small video on what is happening inside an engine. This is just graphics, so it's not a real engine which is being shown, but it explains what's going on. I want to explain what's happening. Now, if you look at an engine, these are the parts of an engine. So this is what is called an engine cylinder. This is basically called the engine cylinder, and which is nothing but a cylindrical hole, I can say. And this is a piston which moves to and fro. The, these are valves which allow the mixture of petrol and air to come in. So this yellow shade which is showing is the mixture of petrol and air coming in. This is what's called a spark plug. Spark plug is electrical equipment where when the electricity passes through it, it creates a spark, which is a small flame, I can say, a small flame. And this is another valve through which the the waste gases can escape. Now let me run this video. Now you can see what's going on. So, so you can see that this is what is called the intake valve through which the mixture of petrol and air is coming in. Then, so that happens when the piston goes down, this enters. The spark, then what happens is the piston starts going up. At that point, it presses the mixture of petrol and the air, and then at that point you can see what happens. You can see that, did you see the white color which comes near the spark plug? That's a spark. That's a small flame which ignites this petrol and oxygen combination, which leads to combustion of petrol. And when the petrol combustion happens, a lot of release of energy happens. It's like a small explosion. And when that release of energy happens, that energy pushes the piston down. So it's pushing the piston down, and then after that, when the piston, you can see this, after that when the piston moves up, it pushes out the carbon dioxide and the waste gases which is left after the combustion out, and then this continues. So first the petrol air mixture comes in, then the piston moves up to press it, then the spark comes from the spark plug, and then that leads to combustion of petrol, which leads to a lot of release of energy, and that energy pushes the piston down, and then piston comes up again and pushes all the the carbon dioxide and all the waste gases produced out of combustion. Then again the piston goes down. At that point the petrol and air again comes in. Then again it presses the mixture, and then the spark plug again sparks. The combustion happens, energy release, and this goes on. And this goes on hundreds and hundreds of times every minute. And that is how the energy is produced, the mechanical energy. So the heat energy is converted to mechanical energy because this piston is converted is connected to the piston rod, which pushes what you call the transmission rod, and so on. And then there's a big story, so I don't want to get into that, but I want to just tell you that a very important point that you remember is that in the car engine the energy is produced because of combustion. That's all what I want to tell you, which leads to a release of lot of heat. That's why if you touch the engine just after you come back from a trip, touch the engine, or you even take the hand very near the engine, only do it when your parents or the teacher is around with you. Not supposed to go near the engine without that, right? You should have your parents or your teacher with you when you're doing that, because you need to do it safely. So if you keep it near anywhere, in fact you need not even go near it, you just go near the bonnet of the car and you can see the heat. It's because inside the engine there's combustion going on, a lot of heat energy is being released, and that is how the engine runs. I hope you had fun listening to this module. I'm just going to sum up. In the module 1 we have discussed what is heat energy. We have looked at what are the various changes that heat energy can bring. It can bring in changes in your state. It can bring changes. It can bring chemical changes, and it can bring changes uh, in dimensions, because it can lead to expansion and contraction of substances because of heating or cooling. Then we looked at the different changes of state. We looked at melting, freezing, vaporization, condensation, evaporation, sublimation, right? And then we looked at how the heat energy can bring chemical change. We discussed what is combustion, and that is what we discussed. So we will move into module 2, where we will continue with heat and discuss about more things about heat. Till then, see you. Have a nice time. Bye bye.